Some of the strongest components in the world begin here. This factory builds springs measured not in inches, but in tons. Each spring begins as a single length of high-strength steel. The forces inside this factory demand respect.
Some of these springs grow taller than the people who build them.
Strength begins at the molecular level. Every millimeter changes how the spring behaves. Small defects can grow into catastrophic failures. Even raw material handling requires precision. From here, the shaping process begins.
Before shaping can begin, the steel must be perfectly straight.
Before shaping can begin, the steel must be perfectly straight.
Even slight bends are corrected here.
Pressure is applied in measured increments. Laser systems confirm straightness in real time. The steel now meets strict alignment tolerances. Length determines how the spring will perform under load. Each cut must be exact. Now, the steel is ready to be shaped. Temperature is raised gradually to prevent cracking. At this stage, steel becomes pliable. Uniform heat ensures predictable forming. Now the steel is ready to be shaped. Moving heated steel requires absolute coordination. Timing here determines the spring's final geometry. This is where straight steel becomes a spring. This machine shapes steel using controlled force. The steel begins to yield under force. This is the foundation of the spring. Spacing determines how the spring will compress. Human judgment remains essential. The spring grows one turn at a time.
At full size, these springs dwarf their builders.
Torque must be adjusted continuously to prevent internal stress. Sensors constantly verify spacing accuracy. Corrections happen in real time. The final dimensions are carefully achieved. The spring is released while still hot. Even after forming, the steel remains dangerous. Cooling locks the spring's shape. Cooling must be controlled, not rushed. The shape is now fixed. But shaping is only the beginning. Forming gives shape. Heat treatment gives strength. Inside, internal stresses are carefully controlled.
Even a few degrees can change the steel's behavior.
Time is as important as temperature. The steel's internal structure has changed. Strength must be measured, not assumed. The steel now meets its mechanical targets. Tempering balances strength with flexibility. Tempering removes brittleness. Now the surface must be prepared to endure years of stress. To survive millions of compression cycles, the surface must be strengthened. Here, strength is built into the surface itself. Uniform coverage prevents weak points. The surface is now compressed and strengthened. Next, the spring is prepared for real-world use.
After hardening, precision becomes the priority.
Perfectly flat ends ensure even load distribution. Surface quality is critical at contact points.
Dimensions are checked to the millimeter.
Dimensions are checked to the millimeter.
Both ends must perform identically.
Protection is the final step before service. Now, the surface is sealed against the real world. Protection begins with a controlled surface treatment. Every surface must be evenly sealed. Thickness matters as much as coverage. Heat transforms the coating into protection. Curing time determines durability.
The spring is now sealed against corrosion.
Only testing remains. Before deployment, every spring must prove itself. Measurements must be exact before force is applied. Load is applied gradually, not suddenly. The curve reveals how the spring will behave in service.
This is the moment of proof.
Some springs are tested for millions of cycles. This spring is ready for the real world. After testing, the spring is prepared for transport. Protection ensures the spring arrives unchanged. Every spring is fully traceable. From here, the spring leaves the factory. From raw steel to engineered force.